Okay, so I had this interesting question asked from a QT I was working with this past week, and to be honest, there may have been some language barriers between the student and the teacher of that course, because the course instructor doesn't speak English very well, so it was a little bit confusing. But I think I got everything worked out okay now, because I was trying to arrive at the answer that the student was given. So the questions were based on the scenario where there were these pencils, there were wood and graphite pencils. There were 100 wood and 100 graphite pencils for a total of 200 pencils. And there were 21 defective pencils out of the 200, meaning 200 minus 21 is 179, non-defective. There were seven defectives among the wood and 14 among the graphite. Now, it wasn't given as a table. I just created the table. Sometimes it's good to create these tables just to work everything out. So the question was, I think the question that was asked was, what's the probability of the pencil being wood and defective? However, the answer given was the probability of the pencil being wood or defective. So I wanted to work this out correctly. Again, sometimes you get these questions when tutoring, and it's just so hard to work them out right away because they're so confusing at the moment. You have to, when you're working with students, you have to understand that every professor, every teacher teaches students in a different way and has different expectations. All right, so what's the probability of being defective? If we look at this table, it's 20, there were 21 defectives out of 200. So 21 divided by 200 is 0.105. The probability of being wood, well, there's 100 out of 200, and that's simply zero point 0.5, which is also the probability of being graphite, right? Remember, probabilities always have to add up to 1, right? For all possible events within a sample space. And the event here could be being wood or being graphite, could be being defective or being non-defective. It always has to add up to 1. So the probability of not being defective, if the probability of being defective is 0.105, is 1 minus 0.105 or 0.895. So what's the probability of being wood and defective? Well, you could just go to the table and find the nexus of the two, right? Or the intersection of the two. They intersect at 7, right? There's 7 is wood and defective. 7 divided by 200, you get 0.035. So that's the simple answer. Using the multiplication rule, so this is the multiplication rule. It's the and I'm using just the symbols A and B at first. Probability of A given that B occurred, whatever B is the probability of A intersection, that's the intersection symbol, intersection B divided by the probability of B. That's probability of B is always a condition, right? You always have a condition in the denominator. Rearranging this equation to isolate the probability of A and B, we get the probability of B, probability of A and B, and an intersection are the same. Probability of A and B is equal to the probability of B times the probability of A given B. So I'm just rearranging this equation, right? I'm multiplying both sides by the probability of B. So let's say wood is equal to A and B is defective. So A is wood, B is defective. We're just playing, I'm just basically redoing this equation. The probability of being wood given one is defective. Well, there were 21 defectives we saw on the table, and of those 7 were wood, so the probability is 0.333. 7 divided by 21. The probability of being defective, there were 21 out of 200 defectives, it's 0.105. All right, that's what we got. So what's the probability of being wood and defective using the equation? We have the probability of being defective times the probability of being wood given defective. Okay. Now, I also do it the other because you could say, well, which one should I choose, right, to be in the denominator? So it doesn't really matter in this case. It only matters if you're doing the what's called the Bayes' equation. Well, we're not covering that here. But the probability of so it's either the probability of being defective times the probability of being wood given one is defective, or the probability of being wood times the probability of being defective given it's wood. So for the first scenario, probability of being defective is 0.105. Probability of being wood given one is defective is 0.333. So we get 0.034965, or we could just round it to 0.35, 0.035, which is the same as if we did it the other way around. Probability of being wood is zero point 0.5, probability of being defective is 0.035. So if we can check our work by going up here, right? Just in the table, we had 7 divided by 200 is 0.035. So those are the same. Down here, now see the problem was that the answer the instructor gave was 0.57. But the question given was what's the probability of being wood and defective? So that answer would have been 0.035. So something is wrong there. So let's look at the probability of being wood or defective. So this is using the addition rule of probability. There's all these different rules you have to know. Addition rule, multiplication rule, there's rule of complementary events, etc. Uh, so the probability of A or, this is the union. Union is translated as or, and or in probability translates to addition, just like and translates to multiplication. So using the multiplication rule, and I'm doing this again with symbols, probability of A or B is equal to probability A plus the probability of B minus the probability of A intersection B. This part is important if we are dealing with non-mutually exclusive events. If they're mutually exclusive, it means they cannot co-occur. This would be 0. So in this case, we have the probability of being wood or defective is equal to the probability. Again, I'm going A is wood and B is defective. Probability of being wood plus the probability of being defective minus the probability of being wood and defective. So the probability of being wooden is 0.5. The probability of being defective is 0.105 minus the probability of being wooden and defective. We get 0.57, which is the answer that we should have gotten. So there was clearly a misreading of the question that threw everybody off. Thank you. So this is a quick little exercise. Hope this is helpful.